Welcome back to our system design art series. In these videos, we are going to explore late limiters, a crucial tool for protecting your system from overload, ensuring stability, and maintain a smooth user experience. By the end of this video, you will know what a rate limiter is, why it is important, and how to implement it in your system design interviews. Okay, so imagine you are running a website and suddenly there is a huge spike in traffic. Maybe it's because of promotion, or maybe it's due to like a distributed denial of service attack or DDoS attack. In either case, your servers are getting bombarded with requests, and if left unchecked, this could lead to system failure. This is where late limiters come in. They help control the number of requests coming into your system to keep things running smoothly. So let's take an example to understand how the rate limiter working. So we have a client, and this client is sending a request to the server directly. But might the server send too many requests to the server, and the server might not have the capacity to handle all of these requests, or might our client is not a regular client, it's just a like hacker or someone wants to put our server or our application in danger by sending too many requests. So we have to protect our server and our system from these attacks, or maybe also to make sure our users have a good and easy experience, because let's say that if someone is sending too many requests, this will impact our system, also will impact our users experience as well. So what is happening here? So what will happen is that we we have a rate limiter. So let's put the server here, and let's say that we have a rate limiter. And let's make the rate limiter quite big. So when the client is trying to send too many requests to our server, that the server cannot handle all of them, all the requests will go through the rate limiter first. If the rate limiter see like a pattern, or the rate limiter see the client has passed the requested, or like the legally authorized amount of requests per hour or per minute. Let's say that the rate has a rule that each client should send 2 requests per minute, for example. So if our client sends 4 requests per minute, the rate limiter will reject the other 2 requests to make sure our system is secured and it's not overwhelmed with requests. So a rate limiter is a mechanism that controls the number of requests a client can make to a server over a specific period of time. By limiting the rate of incoming requests, you can ensure that your servers are not overwhelmed, and you can maintain consistent performance for all users. So rate limiters act as gatekeepers, preventing users from making too many requests too quickly. This is especially useful in public APIs, where allowing unlimited requests from a single user could consume excessive resources and negatively impact other users. So let's try. There is multiple ways of how actually the rate limiter working. There is like a token bucket, because in this algorithm, tokens are generated at fixed rate and stored in a bucket. When a user or when a request is made, it need a token to process it. If tokens are available, the request is allowed. If not, the request is blocked or delayed until tokens become available. There is a leaked bucket. And the leaked bucket algorithm controls the outflow of requests like water from a leak bucket, ensuring a consistent flow rate. Excess requests are either dropped or delayed until the bucket has capacity. There is a fixed window um, a fixed window or sliding window. These algorithms count requests within a specific time window. The fixed window approach counts requests per defined period, like 100% per minute, whereas the sliding window provides a more flexible approach, tracking requests in overlapping time periods. And in the future, we will create a videos that talks about each of these algorithms in details, and we might code them in yeah, we might code them in the future. So these algorithms help you control the rate of the request, ensuring that your servers are not overwhelmed and can continue serving users reliably even under a high traffic conditions. So the benefits of using the rate limiting. First, preventing overloaded. Rate limiters help protect your systems from being overwhelmed by too many requests, which can lead to slow response times or even complete failure. Number two, ensure fair use. By limiting the number of requests a user or client can make, you can ensure fair resource usage and prevent a single user from consuming excessive resources and at the expense of others. Also, it has a DDoS protection. Rate limiters provide an initial layers of DDoS attacks mitigation by limiting the number of requests that can reach your servers, helping to protect against attacks aimed to overwhelming or overloading your infrastructure. And also, it also provide a cost control benefit, because rate limiting can also help control operational cost by reducing the load on your infrastructure, which is particularly important for applications that scale based on resources. Um, what is next? I guess we are done. To sum it up, rate limiters are essential for protecting your systems from being overloaded, ensuring fair usage of resources, and providing an extra layer of defense against DDoS attacks. Implementing rate limiting in your system design helps maintain stability and ensure a reliable user experience even during traffic spikes. So if you enjoyed this video, make sure to like it and subscribe more for more system design insights. In next video and next episode, we will explore distributing message queue. We might do that, or we might go into this to discover the microservices. I'm not so sure about it yet, but we will discover it later. So yeah, that's it for this video, and see you in the future.